as 2x over 2x minus 5 plus 7 equals to 5 over 2x minus 5. And what I'm going to do is I'm going to bring this term to the left by subtraction and take that term to the right by subtraction. And so that gives me 2x over 2x minus 5, and then subtract this term, minus 5 over 2x minus 5 equals to negative 7. So I just shifted those terms around a little bit. Now over here I have a common denominator, so I can combine these terms together. And lo and behold, becomes 2x minus 5 on top equals to 7. Well, what is 2x minus 5 over 2x minus 5? That would be 1, wouldn't it? Because you're dividing a number by itself here. So I end up with 1 equals to 7, which is impossible. So this problem cannot be solved no matter what angle you look at it. There is no way to get an answer that's going to fit. We forced the issue with this technique, and that shows us that this solving technique, where we multiply each part of the equation by some kind of algebraic term, that technique has a potential flaw in it. And this is an example of where that flaw manifested itself. So we're going to see this again in a couple of areas of this course. For example, if you squared both sides of an equation, suppose you had minus 1 equals to positive 1. That's obviously wrong. But if you squared both sides, now it becomes right. So a technique in which involves squaring both sides of the equation can lead to a wrong answer. And there's some techniques with logarithms that can lead to wrong answers. And so there's a few of these in math where we're laboring under a small problem. Our technique is not foolproof. It can fool us. We can solve a problem, get an answer, and the answer is wrong because the technique had a little flaw in it, which we can only expose by checking your answer. And so that's why, I did this first of all. I checked my answer, and we had division by 0. No solution. So there we go. Like I said, we'll see this sort of phenomena in different ways throughout the course.